Hello everyone, my name is Vishwa Mohan and I welcome you to this amazing new course that I'm starting on YouTube, which is Data Structures and Algorithm in JavaScript. Conventionally, if I go and talk about JavaScript, has not been used for writing the codes for the DSA itself. Normally, for the DSA, you would go and prefer the programming language like C++ or Java, feeling as if they get you the competitive programming edge. But that was the story of the past. I strongly feel in the modern world, not only doing something important is enough, but also something which is relevant. So in the modern world, if you're in college, if you're a professional and you want to become a full stack developer, if you want to work on a JavaScript stack, for you it definitely doesn't make sense to go and learn data structures and algorithm in other programming languages like Java and C++. Now, knowing DSA is must, but what you should do is that in the year 2024 and going ahead, if I have to master DSA as a full stack developer in JavaScript stack, I should do it in JavaScript itself. So this is one place solution for you people. Will try to make sure that anything and everything which is needed for you to master DSA in JavaScript will be done in this single playlist. Everything, all the possible questions of the world, everything which is needed to crack all the big companies, all the FANG, MANG, all the product based companies, everything will be covered. What I only expect from the return is that a little love. This is a new YouTube channel, show some love, write the comments, put some likes and tag me over the Instagram or LinkedIn and tell me if you guys are enjoying this course. So let's get started with the data structures and algorithm in JavaScript. So now let's get started with the data structures and algorithm with Vishwa Mohan, right? So typically we know that we're going to master this data structures and algorithm course in a programming language or a tech stack which is JavaScript. So by now you would have already understood that to do the best out of this course, you should be already aware of a programming language which is JavaScript. Said that DSA is language agnostic. What it means that it is pure logic, does not matter which programming language that you code for. So even if you come from other programming language like Java, C++, the logic still remains the same, the concept still remains the same. So you can still make use of the videos and try to write the code in the best programming language of your choice. But this one where I'll be writing code, I'll be writing the code in JavaScript. Let's get started. So let's quickly start with a very basic thing, that what is data structure. Just pause this video and if you know that, put that into the comments. As per one of the study, if you try to participate, whether it's a live session or a recorded session or it's a YouTube session, your focus increases by 30%. So now let me know what is the meaning of data structure. Data structure, if I go and put in a very simple word, sir, right? It is made of the two words, right? It is made of the word called as a data and it is made of the word called as structure. So in very simple words, what I mean to say, the data structure is nothing but structuring the data, structuring the data. When you put the data in the right way, when you arrange the data in the right way, that typically is called as data structure. And why do we do it? We do it so that we are able to achieve two things. But before I go and talk about, let's talk about the real world, right? See, this concept of arranging things is not new only to the world of the programming, right? It's also relevant in the real world as well. I'll give you an example. For example, let's say that whenever I have to travel, right? Let's say that whenever I have to travel, I am very bad at packing my bags. So what happens whenever I have to travel? Let's say that I have to go Goa. What I'll do is that I'll just open my bag, right? My suitcase, and I'll just randomly dump my t-shirts. I'll dump my jeans. And because I'm randomly pushing my clothes inside this bag, hardly I would have kept say like 3-4 t-shirts and 2 jeans, and my bag starts getting overfilled. It feels as if no other space is left to add any other cloth in there. But on the contrary, sometimes let's say that assume that my mom is also traveling in the same, is traveling with me and he is helping me kind of pack my bags. Typically the way she arranges the clothes, he will always fold the shirt, fold the pant. In the same bag where I was only able to fit in 3-4 t-shirts and 2 jeans, when my mom does, she's able to fit in at least 6-7 t-shirts, at least 4 to 5 jeans, plus towel, plus snacks, and still a lot of space is left. Can you guys relate it? Sometimes make your mom do this packing for you and realize that how well they pack things. And because of packing things well, because of arranging items well in a suitcase, a lot of space is left unoccupied. So one of the advantages that I see here is that when you arrange things well, typically you get the first advantage that you save some space. Save space. But that's not all. When I reach Goa, and let's say that if I have packed my bag, and I have to pick that yellow t-shirt that I thought that I'll wear and I'll walk through the beach. To take out that t-shirt, what I'll have to do? I'll have to open my suitcase, I'll have to take all the clothes out, and then finally I'll find that yellow t-shirt that I was looking for. It takes me a lot of time. On the other hand, if I ask to do the same job to my mom, let's suppose that she is also traveling with me, she knows exactly where that yellow t-shirt is. She will just tilt from the left, put her hand inside and take out the 4th t-shirt, and that will be the yellow t-shirt. The point that I'm trying to tell you is that when you go and make use of data structure and algorithm, when you make use of data structures and algorithm, basically what you're trying to do, you're trying to structure the data, And why you're trying to structure data? You're trying to structure the data because you want to achieve 2 things. You want to optimal storage, you want to achieve the optimal storage, that's number 1. And the second thing that you would want to have is that you would like to have the the fast computation. Fair enough. This is the main reason why you go and make use of data structures. If I give a more relatable example, let's assume that let's say this is the line, and let's say this is the year 2024, and this is the time when the human civilization started. Human civilization started. Let's say this is the time when the human civilization started, and this is the year 2024. And let's say that from the time the human civilization started to the time, the current time, X is the total amount of data which was created. Now can you make a guess that 90% of this X would have been created in how many last years? If X is the total amount of data which has been created from the time the human civilization started in year 2024, 90% of the X has been created in the last 2 to 3 years. What I'm trying to say is that today's data is being created at a very large volume, at a very high veracity, very high velocity. Almost any organization, any company that you go and work for, be it social media, be it search engine, be it edtech, be it space, be it health, be it banking sector, almost every sector has become data hungry. Almost every company today has to deal with the data, play with the data, and using the data, they say that I go and take the data driven decisions. This is the today when people are talking about doing data driven decision. People are saying the data is the new oil. Now since every company has to deal with the huge amount of the data, they are dealing with these 2 problems. Problems of storage, problem of computation. So when you know data structures and algorithm, with data structures, be specific, it helps you to store data in an optimal way so that you save some space. And also when it comes about querying, it is stored in an optimal way. When you query it, it's queried get fast. And that's how the computation could be made fast. And that's the reason why almost every company these days, big company, small company, medium sized startup, almost every company, if you go and be a part of that company in the beginning, they will have at least 2 to 3 rounds of coding for you. And if you are a JavaScript developer, full stack developer, the very high chances that people will expect you to be aware of DSA so that you are able to optimize the code that you're writing. Now since we have understood that what is data structures, why do we need data structure, let's try to move to the next topic, which is algorithms. What are algorithms, right? So let's try to understand what are the algorithms with a basic example. Okay. So let's say that, for example, I stay here in Bangalore, this is my home, and let's say that I want to go to the airport. My problem statement is that I want to come out of my house and go to the airport to pick my flight. Now to reach airport, there could be multiple paths, right? One of the path could be that I go to the point A, then I go to the point B, and then I go to the point C, and then I go to the airport. This is one possible way of going to the airport. The another possible way is that I go to point A, from point A I go to the point D, from D I go to the point E, and from E I go to the airport. Or there is an altogether new path, which is I go to the point F, I go to the point G, I go to the point H, and from H I go to the airport. Now for a given problem statement that I want to go to the airport, there are different solutions, there are different paths. Each of these paths or each of these solution of the problem that I want to reach airport is called as a algorithm, right? So algorithm in a very basic sense means that the logic, basically the logic to solve the problem. The algorithm is nothing but the logic to solve the problem. Any problem that we have at the hand, the logic which we go and apply to solve that problem, that's typically is called as algorithm. So in this course, I know that almost all the companies are going data crazy, right? So with the data, we want to deal with two things: efficient storage and efficient computation. So no matter which company that you go and join for, no matter which company that you go and work for, be it startup, product-based company, small company, big company, almost every company will be dealing with this problem of efficiently store data and efficiently compute data, and for that, data structures and algorithm becomes very, very important. So whether you want to be a good coder at the work, at the office, or you want to go and crack the tomorrow's big interview, almost everywhere DSA is exceedingly important. Now since we have understood what is a data structure, what is an algorithm, let's move on and see that what we'll have to do. So now expectations to excel in this course. I understand that this course is free, it is available on YouTube, but I want to make sure that I give you the best structure possible to this course. You feel as if you have not paid by money but the time, and you're making the good return out of this investment of time that you're doing. But for doing that, to make the best out of this, there are few expectations which I hold from you people. You should have a basic understanding of JavaScript. You should be comfortable that how do you write the for loop, while loops, conditional, if else block. And then you should also have some machine to write the code, either a laptop or a notebook, anything that should be the fine. If you can write the code with the pen and pencil on a piece of a paper, or if a laptop, then you can write the code and execute it. So these are the three things. And then the last one is the desire to learn. So first three things are, I will only contribute that to learn things, you will only let 10% of this will contribute to actual learning, right? The biggest motivation or the biggest reason for you to excel would be that when you go and learn this fourth one, which accounts for the 90% of the motivation, the 90% result will come when you will have the desire to learn. So only thing which will make you succeed in this course is that you make sure that you're watching all the sessions properly, you're doing all the assignments, you're solving all the problems that I'm doing it here, and you're not leaving anything for the backlog. If you do all this, trust me, I promise you that I'll make sure that till end I'm there with you people. If you're investing X, I'll make sure that your investment turns 10x. But for that I need that little sincerity. Can I expect a little promise from you people that till the time this course is not finished, you guys will not lose momentum, you'll watch all the videos, you'll do all the problems that I'm doing here. Can I expect that little promise? Put that promise into the comments so that I know that you guys are studying with me and you're sincere enough. Fair enough? Cool. So this is what the expectation from you people is in this course, and now let's move on. So if I go and talk about, the entire course, what should be the journey of learning the data structures and algorithm? right? So data structures and algorithm comprise of DSA, right? So before we get started with anything in the DSA, there are two basic prerequisites, or I go and call it as the concept 0 that you should go and master. Those two concepts are called as, one is called as algorithmic analysis, algorithmic analysis, which goes and tell me that if this algorithm is good, this algorithm is bad, that's number one. And the second part of that is called as a recursion. Recursion is also a kind of a concept which is used in almost all the complex algorithms that we go and see going ahead. So these two things will go and learn as the concept 0. These two things will learn as the concept 0. And once that is done, then we'll try to deep dive into the field of data structure and algorithm. The whole planner that how this course will run, you will find it attached in the description. Every video that you see, there will be a list of the question that I go and solve it, more of like a DSA sheet, which you will find as attachment in the description. And any question or doubt that you have, since right now I am only on the YouTube, you can just put your questions on the YouTube comments. I will myself respond to your comments. Okay? So now let's get started and move deeper into the world of algorithmic analysis. So in this video, we're going to focus on one concept, which is the algorithmic analysis, analyzing the algorithms. So now let's get started with understanding the algorithmic analysis, right? So algorithmic analysis means that I know that, all the time to solve any problem, there will be many solutions to it, right? There will be a algorithm 1 which can go and solve it. There's algorithm 2 which can go and solve it. There's algorithm 3 which is going to be solve it, right? So we should have some way so that we can go and analyze this algorithm so that I can deem fit that, okay, to solve this problem, which kind of algorithm is the most fitted solution? Which algorithm should I use to solve this problem? Which algorithm I should not use, right? So algorithm 1, algorithm 2, algorithm 3, out of these 3 algorithms, which algorithm can best go and solve my problem? This is what I want to go and do with the help of the algorithmic analysis, right? So now to solve this, let me ask you a question. There's a question on a screen right now. Let's say that there is a problem P which you have, and to solve this problem P, you have two solutions. Algorithm A1 which takes T1 second, and there's an algorithm A2 which takes T2 second to solve the problem P. And then you have been told that T1 is less than T2. It means that algorithm A1 takes less time to solve the same problem P than the algorithm 2. Then if that is the case, can I say that A1 is better than A2? If A1 is lacking test time to solve the same problem P than A2, can I go and say that A1 is better than A2? What do you think? Just pause the video. Think, write the notebook, put that into the comments and let me know that what do you think, is A1 better than A2? Most of the time when I teach things online or offline, most of the time in my experience, 99% of the time the people have said that yes, A1 is better than A2. But unfortunately, this answer is totally wrong. Unfortunately, this answer is totally wrong. And the reason you are not able to find it, because most of the time this time complexity is considered as most like a not a topic that you put too much of importance, right? You take it for granted. You feel that I know it, right? So this answer is incorrect. And so let's say that many of time when I go and ask the people that what is what is a better definition of an algorithm, who is better, people say that one which takes the less time. But this is not right. The correct answer to this question is that it depends. Because whenever you have to go and solve factors on which the time depends, it depends on multiple factors, right? So when you have to solving a given problem, and let's say to solve this problem you have an algorithm. Now how much time this algorithm will take to solve this problem will depend on multiple factors. Definitely yes, the first factor itself is the logic itself, that how good the logic that you have written. A good written code should take less time, a badly written code should take more time. So first of all, definitely the logic is the culprit, that's number one. The number two is also dependent on the operating system or the processor. So depending on which machine that you're writing code, let's say that you're working on a multi-core modern processor like Mac, and the same code if you go and write on an old Windows machine, typically the one which you write on a multi-core processor will definitely take less time, right? It also depends on the programming language, choice of the programming language. For example, if you write a code in C++, it will take you less time. If you write the same code in, say, for example, Python, it might take little more time. So the absolute time which a code takes to run not only depends on one factor but multiple factors, and those multiple factors are logic, operating system and the language. So when I was talking about this problem about the algorithm A1 and A2, unless until I know all these factors, if I just consider the time as a measure or as a metric to determine if the A1 is better than A2, it will not give me a right picture. Because here I am not talking about the time, but I am talking about which algorithm is better. Think of it like this, algorithm is a logic, and if a logic is good, it should be independent of operating system. It should be independent of programming language. It should not happen that, hey, I have written a piece of a code, it works great in C++, but if you write in JavaScript, it might not perform. Will that happen? The logic which is good has to be good at all the places, right? And same, it should be independent of operating system. So an algorithm quality, if I go and talk about that, I want to go and measure algorithm quality, it should be independent of programming language. And as I was telling you in the beginning itself, when you're learning DSA, it's not that it has anything to do with the C++, Python or JavaScript. The learning, the concept that we go and get in this session will be independent of the programming language, right? So independent, so algorithm quality, right, should be independent of the programming language, independent of operating system. So I have to find a concept which will help me to compare algorithms, which will help me to compare algorithms and compare in a such a way so that it's not dependent on programming language, it's not dependent on the operating system. Then how do I do compare the algorithms? For comparing the algorithms, then I use a concept called as time complexity. I use a concept called as a time complexity. Very important concept going at every problem. Once we have mastered that, every question that we go and solve, we'll try to identify what is the time complexity, how do we find it out. And also when you go in the interviews, companies, every time the problem is asked from you, they will ask you that, boss, you have solved this question, now you tell me what is the time complexity of it. And our intention while working in the industry, for the companies or in the interview, is to write a code which have a lower time complexity. Fair enough? Now let's try to move on. So we are getting started with a concept called as a time complexity. So first of all, let's try to understand that what is this? What is a time complexity? Again, most of the time when I go and answer this question, most of the people give me an answer which is wrong. Can you just pause this video and put that into the comments? What is the time complexity for you? Most of the time, the most commonly heard answer that I get about the time complexity is the time taken by an algorithm. Time complexity is nothing but the time taken by the algorithm. Do you think it is the right definition? This definition is utterly wrong, because if you go and take the time taken by the algorithm, it will again get dependent on the programming language, it will get dependent on the operating system. I know that this time complexity has to be independent of these things, it should be independent of these things. So if it has to be independent of this thing, time complexity definition should be such that, so that no matter which programming language you use, no matter which operating system machine you are using, you are getting the same time complexity for a given algorithm that you have written, right? So the real definition of the time complexity, I'll first define it and then I'll give you with the examples that how do we go and find it. Time complexity says that time complexity is nothing but how the number of operations varies with input size. Time complexity says that how your number of operations is varying with the input size, and that will go and define the time complexity of a problem. Let me help you with a example. Let me help you with help of an example. Let's say that I have written a code like this: function print, and I take an input call as n, and inside this I go and print something called as console dot log, and then I go and say that hello. Now if you see here, what is the input size? This is the input size. What is the operation? This is my operation that I am doing. I am trying to print hello. So no matter what is the input size, whether n is equals to 0, then only how many times I am printing? No. Operations, how many operations that I am doing? The operation is printing. I am doing only one. If n is equals to 100 also, if I go and pass, how many times hello will be printed? Only once. If n is past 1 billion, then also number of operation hello that is printed is 1 itself. So what I am saying, the number of operation is independent of n. So in that case I go and say time complexity is constant, and I go and represent it as order of 1. Time complexity is constant and I go and represent it as an order of 1. If I take another example, I go and say that function print, and I pass n as the input, and then I go and say that for I equals to 0, I is less than n, I plus plus, and then I go and print console dot log, and I say hello. In this case, again this is my input, and what is my operation? This is my operation, which is the printing hello. Now if I say that if here n value is equals to 1, how many times hello will be printed? 1 time. If n is equals to 100, how many times the hello will be printed? It will be printed hello 100 times. If n is equals to 1 billion, how many times hello will be printed? 1 billion times. So what I can see that my number of operations is proportional to the input size, and my number of operation is proportional to the input size. I'll go and say the time complexity is order of n. See, in this I'm not going to teach you the theoretical concepts as if it is you have to need to pass the semester examination. The concept I'm going to tell you is that has to be practical, has to be applied, one which you need to crack your interviews, one which you need in your day-to-day work. That's my whole intention. My only intention is that to help you get the concept which will help you get the jobs. I don't want you to go into the semester style teaching which is very theoretical and has nothing to do with the practical applications. Fair enough? Cool. Let's try to understand with the more examples here and why the time complexity is important. If you see here, I have one simple problem here. What is one simple problem? I want to find the sum of, the problem here is find the sum of first n natural numbers. This is my problem statement, right? To solve this problem, I have three different solutions here, as you can see. This is the first, this is the second, and this is the third. Now if you see, analyze the first one, irrespective of what the value of n is, the number of operations is only equals to 1. So here in this case, if I have to go and find the time complexity, what should be? It should be order of 1. However, in this case, what we have done, we have taken the input, this is my input size, this is my input size, and then I've initialized the variable called as sum, and then I'm running this loop. So the operation here is that this for loop is running, and then I'm incrementing the value of the sum, and then I'm returning it. So the number of operations here, in this case, my number of operations is same as the number of times the loops will run, right? For example, if n is equals to 10, the loop will run for 10 times. If n is 100, the loop will run 100 times. If n is 1 million, the loop will run 1 million times. So number of operations is proportional to how much? N. So in this case, my time complexity will be what? The time complexity will become order of n. Fair? Now if I go and talk about this third portion, here again this is my input size. Here the logic that I have used is, for this loop this runs for the n times, and in this problem statement, if we see here, this is the input size, and the number of operations will be equals to what? The number of times loop runs, right? This will be equals to the number of operations, right? From here, if we see here, the inner loop runs for n times, and this inner loop will first of all run one time, then second term run two times, then run three times, like this will go on. Fair. So my number of operations, if I have to go and operate, will be how much? 1 plus 2 plus 3 dot 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 till n, right? This is how this for loop will execute. This is my number of operations. The 1 till n, what is the value? It is n into n plus 1 divided by 2, which is equals to n square by 2 plus n by 2 plus 1 by 2, right? This is my number of operations. Now, whenever I go and talk about the time complexity, I will always talk about the proportionality. I will always talk about the very large values of n. So, when the value of n is very large, I can just go and ignore this portion. And I can just say that my number of operations in this third case is proportional to this value, which is equals to n square. So, this will have a time complexity of order of n square. So if you see here, for the same problem is the same, which is finding the sum of first n natural n. In the first case, it takes a constant step, constant number of operations. So it is time complexity is order of 1. The second takes the linear number of operation proportional to the input side, time complexity is order of n. The third one takes the square to the input size, so time complexity order of n squared. So obviously, if in terms of time complexity, I'll say that this one is stack number 1, this is stack number 2, and this is the stack number 3. So based on the logic that you go and write, you always have to ensure that your number of operations are proportionally less with the input size itself.